Hello, mic testing, check 1, 2, 3, 4. Just a quick sound check if I'm audible, if I'm properly visible, and there will be a lag of a few seconds because of this live stream. So, whenever you are able to hear my voice and see the screen properly, if you can just type in a quick response on the chat, I can go about and begin this session. I'm just waiting for some responses on the chat so that I know I'm audible and visible. Hi Ayush, hi Anusha. Audible and visible. Great. Good to know that. So, good evening everyone and welcome to yet another session of live paper analysis and solutions with me, Sathya. If you have been following this channel, or even if you go and see my IQ Digital channel, I have been doing these live sessions where in the past I solved a couple of papers of PDEU, the SLS School of Liberal Studies for Pandit Dindayal Energy University, formerly the PDPU. And I also had 2 sessions of IPMAT 2024 sitter questions and one on a lot of short answer easy questions from the past papers of the IPMAT of IIM Indore. And a lot of students who attempt the IPMAT, especially the one by IIM Indore, also attempt the NPAT by Narsimonji, NMIMS. And the sample paper for 2025 is officially available on their website. And a lot of students were asking me questions from that, or just saying, is this easy paper? Doesn't look easy, looks tough. If this is the level of questions that will come in the actual NPAT, then how do we go about solving, so on and so forth. So I said, okay, let me do this session live of at least the maths questions of NMIMS NPAT 2025 sample paper. So today I'll be taking you through these questions of maths. I think there are 20 questions if I'm not mistaken. Let's see how it goes. I'll try to solve all of them. And of course, the reasoning and the English sample sections are also given in the same paper. But the best part about this is that they've also provided an answer key at the very beginning of that PDF. So even if you're just solving it on your own and you want to cross-check the answers, the answer key is right there, but of course not the solutions. So this session, I'm going to take a look at the questions of NPAT 2025 sample paper. I've also seen questions of past years, and many of those questions definitely seemed easy and doable, and definitely a lot of questions of the sample paper were quite easy. Like I keep saying, even for the IPM IIM Indore paper, if you are clear with your fundamentals, if you don't panic by looking at the notations on the screen, and if you just trust your instinct in many cases, you will be able to crack them. So without further ado, let's start taking a look at these math questions one by one from the NPAT 2025 sample paper, and let's see how we perform. Right, I'll be putting up the question on the screen and solving them. If you can get the solution faster than me, absolutely great. And I hope you do, because I'll be taking my own sweet time explaining it, doing it step by step. And I have had students coming, sir, itna time nahi lagta hai, फटाफट हो जाता hai. Great, because I have to explain it step by step. It takes some time. But now, believe me, 1.5 minutes is absolutely not a difficult task to solve any of these things. Chalo, बहुत सारा बकर हो गया. Let's start with the questions. Functions. This is a favorite of IPM Indore, but NMIMS also seems to have been caught with the bug. So it says given f of x is 1 plus 1 upon x and f of k into f of k plus 1 into f of k plus 2 till blah 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 till f of k plus 99 is equal to 11. Then you are given 2 quantities where quantity A is k itself and quantity B is 11. And from the 4 options you have to select whether quantity A is greater, whether quantity B is greater, whether the 2 quantities are equal, or if the relationship cannot be determined from the information given. And a lot of questions in this sample paper are of exactly this kind, where they just don't want you to solve it and give the answer, but actually take a step ahead and compare 2 given quantities. For functions, my funda is simple. Try to work out the first few terms of the function if possible, and usually you will see a pattern, right? So let's take a look at how this particular question progresses. The very first thing I'm given is that f of x is defined as 1 plus 1 upon x. So that means this is nothing but x plus 1 the whole upon x. Great. So f of x is nothing but f of x plus 1 upon x, which means if I take the value of x as 1, then f of 1 is 1 plus 1, 2 upon 1. F of 2 is 3 upon 2. F of 4 is equal to 5 upon 4, right? So the number itself is the denominator, plus 1 is the numerator. Okay, easy, great. Now what do I have to do? I'm asked f of k into k plus 1 into f of k plus 2 till k plus 99 is 11. And we have already resolved the function easily. So what does it work out to? F of k can be written as k plus 1 upon k. F of k plus 2 is nothing, f of k plus 1 is k plus 2 upon k plus 1. K plus 2. So f of k plus 2 is k plus 3 upon k plus 2. So this keeps on going. And the last term is f of k plus 99. So the denominator is the number itself, k plus 99, and the numerator is plus 1, so k plus 100. And that is given as equal to 11. But so nice. If I take a careful look at it, I have got the terms k plus 1 and k plus 1, k plus 2 and k plus 2. So following this pattern, I will be able to eliminate everything diagonally, which leaves me with k plus 100 upon k is equal to 11, which means k plus 100 is equal to 11k, or 11k minus k, 10k is equal to 100, which means k is 100 upon 10, which is equal to 10. So I get the precise value of k equal to 10. Now my quantity A is 10, quantity B is 11. Which quantity is greater? Come on guys, not a rocket science, right? First standard, junior KG, senior KG, 11 is the greater quantity. So obviously quantity B is greater, has to be my answer in this case. Easy question, sitter question, no great thing, right? You just have to understand the functions notations and just write it down the way it has been presented, and the solution pretty much presents itself. Okay. Guruji, can I choose 2 or 3 undergraduate degrees for NPAT? Okay, hold on guys, let me first solve these questions, and whether you can choose 2 or 3 undergraduate degrees for NPAT, that you'll have to go on their official website and check, right? If it allows you to fill in multiple forms, fine. Otherwise, they will have a FAQ, a frequently asked questions section. They will have their admission guidelines. I would very strongly recommend you go and read all that data. If there is still a confusion, nothing better than just getting in touch with the admissions office there and getting it straight from the horse's mouth, right? But most of this information should be officially written on their website. Please don't follow any third-party website. Go to the official website of the institute, the exam, and get the details straight from there. Chalo. So the first question, relatively easy. Moving on to the second one. Now, again, notations based question looks a bit complicated, but again, I just need to check if x, y, z are positive integers and the value of p is given, then p is less than 6, right? But that's not a statement. It says, is this always true, sometimes true, or never true? Okay. So I just need to identify what is the value of p. Now p, it is given, is equal to, and this looks complicated but it actually isn't. It says this is equal to x minus 1 the whole square upon x plus 2 plus y minus 1 the whole square upon y plus 2 plus z minus 1 the whole square upon z plus 2. So all the 3 terms are the same, only the x's, the y's and the z's are replaced with each other. Now let us understand what these values are going to be. It's given that x, y and z are positive integers, right? So if x is a positive integer, that means its values start from 1. So 1, 2, 3, 4 and all are positive. So the smallest possible integer is 1. 1 minus 1, 0 upon 1 square is 0. So this part can be 0, or it can be, if x is 2, 2 minus 1 upon 2, square of the numerator and x, but x is always positive. So the thing within the square bracket is always going to be either 0 or a positive number, not necessarily an integer but a positive number, and then plus 2. So the first thing is going to be either 2 or greater than 2, right? The smallest possible value for the first bracket is 2, and because everything is symmetrical, the smallest possible value of the second and the third bracket is also 2, which means the value of P is definitely equal to 6 as the smallest possible value, right? And the question asked is P less than 6? Now, if the value of P smallest possible itself is 6, how is P ever less than 6? It's never going to be less than 6 because the values are going to be 6 or more. So, P less than 6 is going to be never, and that's going to be the answer for this particular question. So, the notation seems a bit crazy, but the solution is not. It is just a little bit of logical thinking. And because each of the three parts of the value of P are symmetrical, I'm not going to waste time writing everything down and solving it, because whatever is true for the X portion is the same for the Y, is the same for the Z. That's it. So second question done and dusted, relatively simple. Let's move ahead and check out the third one. And I'll check out my comments too in the meantime. Thank you. Okay, welcome. Okay. Now, it says, if P and Q are numbers such that the pair of linear equations blah 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 is 10 and blah 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 is 10 have infinite solutions of X and Y, then P is equal to Q. Again, is it always, sometimes, or never? Guys, 9-10 standard, when you were introduced to the concept of simultaneous linear equations, solving two linear equations together, the first fundamental concept that you were taught was to identify whether the two equations have infinite solutions, no solution, or a unique solution. And do you remember the funda for that? Let me give you an example. If I say 2x plus 3y is equal to 10 and 4x plus 6y is equal to 20, I have two variables xy, two equations. Can I get a solution to this? And the answer technically is no. And what was the funda that you were taught? That the ratios of the coefficients and the constant, if it works out to be the same, then technically they are the same equation and there are infinite possibilities to it, right? So in this case, 2 upon 4 is half, 3 upon 6 is half, 10 upon 20 is half. So for two equations, a1x plus b1y is equal to, let's say, C1, and A2x plus B2y is equal to C2. If A1 upon A2 is the same as B1 upon B2 is the same as C1 upon C2, then this system will have infinite number of solutions. Now, what do I need to do? I need to apply this concept to the given problem. It says, the things have infinite solutions of x and y. So the coefficients of x, in this case p plus 2 and the ratio with q plus 2, should be equal to the constant, the coefficients of y, that is q minus 1 upon q plus 2, and that should be equal to 10 upon 10, right? A1 upon b1 is A2 upon b2 is equal to A1 upon A2, B1 upon B2 is C1 upon C2. So once I get that particular thing, let's just take a look at this portion, right? P plus 2, Q plus 2, Q minus 1, and sorry, this is P minus 1. This part is just P minus 1. Okay. So cross multiply and check. P minus 1 into P plus 2 is Q minus 1 into Q plus 2. Now, of course, you could expand this and solve, but it's an entrance examination. I don't need to show my steps. So just by looking at the entire equation, if P minus 1 into P plus 2 is Q minus 1 into Q plus 2, then shouldn't P and Q be exactly the same number, right? Because if you are subtracting 1 from both and adding 2 to both and taking the product of both and they're equal, then the two primary numbers must be equal. So logically speaking, P definitely is equal to Q. right? So P is equal to Q is always true. So the answer in this case definitely has to be equal to A. So even without going into the nitty-gritties of the problem, by visually taking a look at the formed equation, I should get it from my gut, trust my gut, that P and Q are definitely the same. And once I get that, I mark this and I move ahead, right? I'm not going to waste time in trying to resolve the entire thing, which of course I can do, but what's the need for that? Great. So let's move on to the next one, the fourth one. Very interesting problem. It says it is given 3 raised to 2x minus 12 into 3 raised to x plus 27 is equal to 0. So first you have to identify what is the value of x, because you need to compare x and 3 to the power x. Okay. So how do I resolve 3 raised to 2x minus 12 into 3 raised to x plus 27 is equal to 0? 3 raised to 2x minus 12 into 3 raised to x plus 27 is equal to 0. Well, 3 raised to x and 3 raised to 2x. But 3 raised to 2x can technically be written as what? Can I write it as 3x the whole square? Right? Because a raised to power b the whole raised to power c is a raised to b into c. So if I rewrite this as 3 raised to power x square minus 12 into 3 raised to x plus 27 is equal to 0, then let's assume 3 raised to power x is equal to a. So now I split it, I create a square minus 12a plus 27 is 0, a simple quadratic equation, middle term 3 and 9. So a square minus 3a minus 9a plus 27 is equal to 0. So a into a minus 3 minus 9 into a minus 3 is 0. So a minus 3 into a minus 9 is equal to 0. So a is either 3 or a is equal to 9, but I've gone with an assumption. So if I say a is equal to 3, then 3 raised to x is equal to 3, which means the value of x could be equal to 1. Or if a is 3, which is 3 square, then I can get the value of x is equal to 2. If x is equal to 1, 3 raised to 1 is 3, second quantity is greater. If x is equal to 2, 3 square is 9, again the second quantity is greater. So in either case, I get that my second quantity is always greater than my first quantity. So I can definitely mark B as the answer and move ahead, right? So although it looks slightly intriguing, it's a very easy problem. All you had to do was understand the rules of exponents, powers and indices, if you remember those fancy things, right? So fourth problem, done and dusted. Right on, let's carry on. Now, fifth. Now, this is one of those easy problems. Time and work, absolutely easy. But let's see whether it is. It says when working individually, A and B take 6 days and 8 days to paint a fence. Okay, now as per my habit, I won't read the entire problem. I will start creating my equations. I'll start writing down what information I have. So A takes 6 days, B takes 8 days. So in any time and work problem, always find out the per day capacity. So per day, A can do 1/6 of the work, B can do 1/8 of the work. So A and B take 6 and 8 days to paint a fence. They started working together. So A and B together per day would do 1/6 plus 1/8, which is equal to 7/24 of the work together. Great. After 2 days, even before reading ahead, in 2 days, how much work did A and B complete? 2 into 7/24. So they completed 7/12 of the work, right? Or 14/24 of the work, which means 5/12 of the work is still remaining. So after 2 days, when 5/12 of the work was remaining, C also joined, and the work was completed after 1 more day. Oh, so 5/12 of the work got completed by A, B and C each working for 1 day. So A did 1/6 of the work, B did 1/8 of the work, C, I don't know, did 1/C of the work, and that was equal to 5/12 of the work. So again, if I take my things, 1 upon C is equal to 5 upon 12. Let's write it as 10 upon 24 minus 1 upon 6 is 4 upon 24 minus 1 upon 8 is 3/24. So 10 minus 4, 6 minus 3, 3/24 is 1/8 of the work. So if C in 1 day did 1/8 of the work, in how many days can C paint the entire fence alone? I've already done the answer, right? The entire fence can be done by C alone in exactly 8 days. So as you can see, step by step, as you keep reading the problem, you keep generating the solution. By the time you reach the end, in many cases, you already have the solution in hand, or at least you are halfway there, right? So easy one. Let's hope everybody understands this. Time and work are usually easy questions. The hack, the mantra is always work out what is the per day amount of work done by the person. Per day, per unit of time. Same funda for pipes and cisterns. Per hour, per day, per minute, whatever unit of time is given. Per unit of time, if you find out the capacity, you can easily work out these problems. Excellent. Now, let's move ahead, see what comes next. Percentage. Ooh, I like percentages. A milk and honey mixture is 20% honey. Okay. So, milk plus honey is equal to total. So, the milk and honey mixture is 20% honey. So, if 20% is honey, so the remaining 80% will be milk, because the total should always be 100%. No doubts there. Another 120 ml of honey is added. Okay. So honey, I have 120 ml more. The resulting mixture has 150 ml of honey. So if this was X and I added 120 ml, I got 150 ml of honey, which means originally the 20% honey was 150 minus 120, which was 30 ml. Great. The resulting mixture as 150 ml means originally it had 30 ml. What is the volume of milk in the final mixture? Now remember, I'm not adding any milk. So in the final mixture, the same quantity of milk that was originally there will be finally present. And originally if 20% was 30 ml, 80%, so 2 4s are 8, 30 4s are 120. So the original 80% would represent 120 ml, which is still part of this. So what is the volume of milk in the final mixture? Answer definitely has to be 120 ml. I hope this is the answer which everybody got. If not, then definitely now you do. Let's move on to the next one. Okay. Ratio. Oh, ratios are also easy to work out, right? Let's see. A, B and C have some marbles. The ratio of the number of marbles with A to the number with B is 2:1. Okay. So, originally I know A is to B is 2:1. Also the number of marbles with A to the number with C is 1:4. So, if I have to compare A to C, it is 1:4. Right. So, 1 the double is 2. So, here 4 the double is 8. So, I can compare A, B and C all together as 2:1:8. Because if 1:4, then when comparing with B, A and C become 2 and 8. So, 2, 1 and 8, great. Now, what is the approximate percentage of the total number of marbles that are with C? So, C has 8. But all of them combined have 8 plus 2, 10 plus 1. So the total number of marbles is equal to 11. Now 8 out of 11 is what as a percentage? You can do 8 divided by 11. But if you have been following my classes, you would definitely know why I keep insisting, remember your reciprocals, remember your reciprocal percentage values. And this is exactly the type of question where that magic number comes into play. I know 1 by 11 is 9.09%. So 1 by 11, if I replace it with 9.09%, 9 eights are 72, 9 eights are 72. My answer is 72.72%, which is option C. Mark karo, aage badho, jal se karo. And do you see it? You might have cribbed all the time when you had to remember those reciprocal values. 1 upon 1 is 100%, 1 upon 2 is 50%, 1 upon 3 is 33.3%, 1 upon 7 is 14.28%, 1 upon 9 is 11.11%, 1 upon 11 is 9.09%, and so on and so forth. And yes, I'm showing off a little, but do you see, these are exactly the type of questions where just because you are able to quickly memorize certain values, you are saved a few seconds of calculation, and believe me, every second matters in an entrance test. So there you go, easy question. A few comments seem to have come. Let me see if I can read. Sir, will such easy questions come in test? I hope they do, because sample papers are usually representative, but even if they are not, even if the sample papers are not, take a look at the actual NPAT papers. If you Google for the past year papers of NPAT, you will come across some or the other source where you can get it. And believe me, I've taken a look at these questions, and I did not think they were too difficult, right? But anyway, I will be taking you through the actual NPAT papers, not just the sample ones, also in classes. And I'll show you, most of them are definitely solvable, or at least you will get enough number of questions to clear the cutoffs, if any, right? So let's not worry too much about that. Some other query. For question 7, if A is 2 by 2 and C is 8 by 2, so can't B be 1 by 2? Yes, yes, yes. See, that's absolutely true. But B is equal to 1 by 2. Do I really need to work with 0.5? I mean, that's exactly what it was, right? I hope you get it. Ultimately, you're going to come to the final same answer, Ayush. I hope you understand that. It's just, I don't like dealing with fractions and decimals, so I try to convert everything into fraction, non-decimals into integral numbers. But either way, 1 is to 0.5 is the same as 2 is to 1. So when possible, I try to just convert everything into integral numbers so that I don't commit a mistake when doing ahead. It's easier to work with integral numbers. If you're comfortable with 0.5, absolutely fine. Right. Okay. Chalo. 7th. Did we do the marbles? Yes, done. Okay. Again, it seems like ratio-y. Let's see. A can draw 10 illustrations in 5 days. Okay. So, per day, A can draw 10 illustrations in 5 days. So, 2 illustrations in 1 day. So, 2 illustrations per day is A's capacity. B is 3 times as productive in twice the amount of time. So B does 30 illustrations in 10 days. So technically B does 3 illustrations per day. Okay. How many illustrations? Are they kidding me? How many illustrations can B draw in 1 day? 3 illustrations. That's it. Why did we even write down this? And I don't know whether they have just put it for sample or is this reflective of the actual level of questions. But I wouldn't be too surprised if this was even the actual level of questions, because when we were doing the past year actual papers of IPM Indore, which is supposedly very tough on the quant section, we came across many such problems which are absolute sitters. And if you haven't seen my last week's live session on 11 absolute sitters from IPMAT 2024 MCQs, then please go see this video. I think it's the live video is stored there. You can see it. And as is common with all these online content creators, like, share and subscribe, like, share and subscribe. I've been saying like that for crazy. I've been saying that like crazy for days together now. Anyway, so easy one. Chalo, let's move ahead. 8th one, sitter can be done. Now this is what? Given A is a right angled triangle and has a side of length 6, 8 and 10, a volume of the cone formed by rotate. I remember this because students came and said that rotation of cone is something which they were not able to understand what exactly is happening. So let's first understand the rotation ka funda, and then we'll see. The question is absolutely easy to solve. So if I have a right angled triangle, right? Let us say this is my right angled triangle A, B and C. I can keep this AB as my pole for rotation, and keeping it like this, I can rotate it around the base. So if this is the thingy, right? This is AB and this is BC. If I rotate the figure like this, AB becomes my height and BC remains my radius. So I'm rotating it around AB. So whichever side you are rotating the cone around, the triangle around to form a cone, is your height. And the other side is your radius. Similarly, if I'm taking a right angle triangle, keeping this and rotating it around this side, then because I'm rotating around BC, BC becomes my height and AB becomes my radius. So a right angle triangle has sides of length 6, 8 and 10. Volume of the cone formed by rotating the triangle about the side of length 6. So if this is 6, this will be 8 and 10. So if I'm rotating it around 6, 6 is my height and 8 is the radius. And if, let us say this is 6, 8 and 10, and I'm rotating the triangle about the length 8, then 8 is my height and 6 is my radius. So now, what is the volume of a cone? The volume of a cone, remember, is nothing but 1/3 the volume of the equivalent cylinder. Volume of a cylinder is base into height. Base of a cylinder is a circle. So base of the circle pi r square, and height is obviously height. So the volume of a cone becomes 1/3 pi r square h. So first case, when the volume is formed by rotating about length 6. So volume 1 will be 1/3 pi r square, which is 8 square, and you have to be careful, right? R square into h. Volume 2 is 1/3 pi, radius is 6 square into 8. And to compare, I don't need the pi's, so I can remove the pi's, I can remove the 1/3s, the 6 and the square, the 8 and the square. So basically 8 and 6, 8 is greater than 6. So in this question, the first quantity is going to be greater than the second quantity always. So I mark option A as my answer. Quantity A is greater. The only thing that you needed to know for this question was, one, what is the volume of a cone? And believe me, people who dread mensuration, which is area, volume, surface area, curved surface area, total surface area, they are absolutely easy to remember because every formula is interconnected. Trust me, you don't have to remember more than 4 or 5 base formulas and a couple of rules. And all those multitudes of, whether it is a cube, a cuboid, a sphere, a hemisphere, a cone, a cylinder, whatever, all those formulas can very easily be memorized. All you have to do is understand the basics, right? So this definitely an easy question, but it sorely depended upon whether you remember your basic fundae of formulas and understand when something is rotated, when a triangle is rotated to form a cone, which is to be taken as the height and which is to be taken as the radius. Okay. Cone. Oh, yet another question of geometry mensuration. Let's see what this question says. A cone fits perfectly height-wise inside a 6 by 8 by 10 cuboid such that the entire base of the cone rests on one of the faces of the cuboid. Okay. Also, the circumference of the base of the cone just touches one of the pair of the opposite sides of the face of the cuboid, which is beneath it. So the volume of the cone is 32 pi centimeter cube. Always, sometimes or never. I will definitely eliminate always as an option because I can think of 3 different scenarios, right? So maybe the always option is not true, but sometimes and never, no. So easier to just actually work it out, and it's not difficult at all. Let's understand the funda, what is happening. So they are saying that there is a cube which has certain length, breadth and height, 6, 8, 10, and the entire base of the cone. So if I construct this as my thing, the base of the cone rests such that the circumference of the base just touches one of the pairs. So remember, because it is not, none of the two sides are the same, it is not going to touch all four sides. So either my base is, let us say, 6 by 8, in which case it is going to be something like this, or it is 8 by 10, right? Or it is going to be 6 by 10. In all the three cases, because it has to touch one, if it is, so the radius in this case can only be half of 6, which is 3. For 8 by 10, when something fits here, the radius is only going to be half of 8, 4. And again in a 6 by 10 thingy, the radius is only going to be half of 6, 3. Because if the radius is, let us say, half of 10, 5, then the diagram, it will go something out like this. If it has to touch the other two sides, it will go outside the box. So the smaller of the two values will determine the radius of the base. And of course, the third value is the height. So what are my three cases here? Let's assume that in one case, my base is 6 by 8. In case 2, the base is 8 by 10. In the third case, the base is 6 by 10. So first of all, the height is the third number. So in first case 10, second case 6, third case 8. And half of the smaller value of the base will be the radius. So in the first case, radius is 3. In the second case, the radius is 4. Again, in the third case, the radius is 3. So I've got the heights and I've got the radii. And I need to find out the volume of the cone. And we just saw in the previous example that the volume of the cone is 1/3 pi r square h. So all I need to see is 32 pi, is it possible as a value? Let's just work it out. So first one, pi by 3, r square is 9, h is 10. So 3 3s are, so this is 30 pi, nope. When r is 4 and height is 6, so pi by 3 into r square is 16 into height is equal to 6. 3 2s are 16 2s are, So 32 pi can be the value, but it is not always the value. So always is out, never is out. I seriously don't even need to work out the third case, right? Because I have another possibility, 30 pi, and 32 pi itself is possible. So clearly the answer is the volume of the cone, 32 pi centimeter cube, is sometimes possible. So again, a very, very beautiful question where what you needed to understand is, one, of course, the formula for the volume of a cone, but second, the construction of the figure. And the fact that in the base, where it is not a square, it is a rectangle, and if the cone is completely contained inside that rectangle, then the diameter of that circle will be the smaller of the two sides. So the radius will be half of that. And of course, the third side is the height. So if you are able to work out that funda in your mind, this question absolutely easy to solve, right? It is not a high funda, high calculation oriented question. It tests your fundamentals and how much you can visualize. And I believe Narasimhanji does put a lot of emphasis on the ability to visualize questions. Because if you go to the reasoning section and check out the questions in the sample paper, so many questions are direct visual questions, no formula, nothing. It's just like fitting in pieces of a jigsaw puzzle. Literally, literally. A puzzle is given with a cutout, which of the following pieces will fit inside that hole, right? So Narasimhanji, at least as far as the sample paper goes, has a lot of visual questions. And I believe those should be very easy to solve, not just by 12th standard students, but even by primary school kids. Anyway, moving on. Done with the 10th question. Let's see the next. Okay. Oh, based on a diagram. Now, I know a lot of people hate geometry, but geometry is fun. Why? Because you can actually visualize the problem right in front of you. Let's see whether we can do that for this question. It says in triangle ABC, AB is 6. Okay. AB, this entire distance is 6. AC is equal to BC. AC is BC. Oh, so it's an isosceles triangle. Brilliant. And it is equal to 7. So both these sides are 7, 7 each. Great. CP is, and AB is 6. Okay, AB is given as 6. CP is a median. Now, what is a median? A point which connects the vertex to the midpoint of the opposite side. So if this is the midpoint of the opposite side, both of these are 3. Great. Which of the following is the area of the triangle? How do I find the area of the triangle? 2 ways in which I can do this. If you are not very confident about guessing, it's not even guessing, actually it's logic, then without doing any guesswork, a little bit of calculation, you can use Heron's formula. Do you remember Heron's formula for calculating the area of a triangle, all 3 sides of which are given? Well, S is defined as the semi-perimeter. So in this case, 7 plus 6 plus 7, which is equal to 20, right, by 2. So that is equal to 10 units. According to Heron's formula, the area of the triangle is semi-perimeter into S minus A into S minus B into S minus C. A, B, C are the 3 sides. So this becomes root of 10 into 10 minus 7, 3 into 10 minus 6 is 4 into 10 minus 7 is 3. So 2 times 3 under a root, take it out single time. This is root of 4, which is 2, take it out, and 10, keep it inside. So this becomes 6 root 10, right? So is 6 root 10 one of my options? Yes, option E is 6 root 10. So if you remember Heron's formula, you can directly apply it and get the answer to this question, right? But what if I don't remember Heron's formula? Is there any other way to do it? Let's try and do something else. So as of now, I know these 2 are same, these 2 are same, this is 3, this is 3, this is 7, and this is 7. Okay. Now, if this is a median of an isosceles triangle, technically speaking, if I compare these 2 things, they are exactly the same, right? Triangle APC and triangle BPC are similar triangles, rather they are congruent triangles. Why? Because 3 and 3, 7 and 7 and PC is common. So by SSS, both of them are congruent triangles, which means both these angles have to be the same. Angle CPA and CPB have to be the same. And because they are supplementary angles, the total is 180 and each of one is the same. Each one of them is technically 90 degrees, which makes it a right angle triangle. And if it is a right angle triangle, Pythagoras comes into play. So I can find out height PC as the square root of 7 square minus 3 square, which is equal to root 40, which is equal to 2 root 10. And once I get that, I got the height, I have got the base. So half into base is 6 into height is 2 root 10. 2 gets cancelled. 6 root 10 is my answer. Again 6 root 10. So if you remember Heron's formula, direct application of Heron's formula. Even if you don't and you want to go in a roundabout way, you can calculate the height of the triangle and then directly use, from using Pythagoras, you can calculate the height. Half base into height gives you the final answer. In both cases, I definitely got 6 root 10 as the answer, right? Easy peasy, lemon squeezy. Chalo. Let's move ahead to the next one. Right. Diagram. But is it easy? I don't know. Let's see. ABC and PQR are 2 identical equilateral triangles overlapping each other. Okay. So ABC and PQR are exactly overlapping each other. Great. So these points are given as X and Y. The area of the overlapping region PXBY. So which is PXBY? Okay. This region is PXBY is equal to twice the area of triangle AXP. So I have got triangle AXP. Okay. Now I have to see whether this is true always, sometimes, or never. It's a visual problem, right? A little bit of confidence in your instinct and we can move ahead. So what do I need to do in this case? I'm going to select a thicker pen. Okay. So all I will do is I will draw a line here joining X and Y. And because I know that they are equilateral triangles, everything should be symmetrical, which means this area PXY and XYB and APX along with PCY, BYR, QXB, all of them have to be exactly the same. And if all of them are exactly the same, then 2 times the same figure is definitely twice 1 time that figure. So, is the area of PXBY equal to twice the area of AXP? Absolutely yes. Visually, I will confirm this. Confidently, I will mark it and move ahead. I'm not going to waste any time trying to figure out formulae for calculating the area and stuff. No, visually I know because it is an equilateral and identical triangle. It has to follow the rules of symmetry. And by symmetry, I easily get the answer to this question. Sitter. Great. But confidence is required that yes, it will be symmetrical. Questions 13 through 16 refer to the following information. Great. So a data interpretation set has been given in this case. Now let us see what exactly the data is all about. It says there are 4 questions based on this set, one of which is asked alongside table. Okay. The table shows the data regarding the percentage change in the number of units manufactured by a plant during different months in year 2. And it starts with Jan till July, but it gives me the percentage change over the last month. And it starts with 10% in Jan. That means I'm starting with a December value, right? So, because percentage, so my base value is 100. So, let's assume that the number of units manufactured in December of the previous year was 100. Now, numbers are given in 2 different rows. The first one is a simple percentage change. So 10%, 18% increase, -5, so dip, 6% up. That is easy. But what is the second row? It says these are percent point change in percentage change over the last month. So when I say -20, this is not 20% decrease. No, understand. It says this is 20. So a percentage point is just numerical value. So this is previous percentage -20, not a percentage, -20. So 18% -20 should be taken as -2%. Again, this is +8, right? So -5% plus 8 is +3%. And 6%, the next is -8. So 6% -8 should be taken as -2%. This was the crucial part of understanding the problem, right? What exactly is meant by a percentage point versus a simple percentage? So if I say my original number is 120% and there is a 20 percentage point decrease. So 20% decrease नहीं है, 20 points decrease. So 120% में से 20 numerically calculate कम कर दो. 120% minus 20 is 100%. So once you understand it is the difference between a percentage and a percentage point, this sum becomes easy to calculate. Okay, although I may not require it, I'm going to actually calculate the value in terms of 100 for each of these months, right? So the first thing is that I've assumed that the month of December had 100 units. The first one is easy. Jan 10% up. So this must be 110. Okay. February was 18% up. So 110 increased by 18%. So 20% will be 22 and 2% will be 2.2. So this should be equal to just 19.8 increase. So 110 plus 19.8. So in February, 129.8 is the value that I'm looking for. Okay. Next is a 2% decrease. So 129.8, 2% decrease. So 1% is 1.298. Let's take it as 1.3. So 2% is 2.6. So 129.8 minus 2.6. So this gives me 127.2. So for March, I will take my value as 127.2. Great. Next, there is a 5% decrease. So 10% of 127.2 is 12.72. Half of that, 6.36. So 127.2 minus 6.36. So 10 minus 6, 4, 11 minus 3, 8, 6 minus 6, 0, 2 and 1. So 120.84. Let's round it off. So I'll just keep this as 120.8. Okay. Next is a 3% increase. So 1% is 1.2, 3% is 3.6. So 120.8 plus 3.6. 8 plus 6, 14, 4. So I can get this as 124.4. Right? Now the next value is 6% increase. So 124.4 plus 6%. So 124.4. 10% 12.4. So 5% 6.2 and 1% is 1.2. So overall 7.4 and that's an increase. So plus 7.4. So 0.8, 131.8. So I'll keep it as 132. Let's see 131.8 or 132. And then 2% decrease over that. So 1% 1.32, 2% 2.64. So 132 minus 2.64. So that will give me 129.36 approximately, right? 129.3. Let's keep it as 129.3. So these are the round figures. I'm not going beyond one decimal point, right? If necessary, I'll do it. But quickly, I calculated the values of all this. Now, let's take a look at the questions. And for ease, I've actually put up these values and not the percentages in the table of each question. Okay. So the first question, and there they are, the values which I just calculated. So the first question says, net percentage change in the number of units manufactured from December of year 1 to March of year 2. In December 100, in March 127. So 27.2 percentage easy because base was 100. So my first value is 27.2 and second value is given as 35 and obviously quantity B is greater in this case. So because I was able to quickly identify the values in the table, the first question became an absolute sitter, right? Obviously quantity B 127.35% was greater than the actual increase from December to March. Done. Moving on to the second question. Now this question says, if the difference between the number of units manufactured in April of year 2, so April of year 2, 120.8 and July of year 2, 129.3. So difference, so 129.3 minus 120.8. So 580. So if 8.5% was 1.7 million, brilliant. 1.7 million, why brilliant? Because 85 twos are 170, 8.5 twos are 17. So actually my working is correct. So if this percentage is 1.7, what was the approximate number of units manufactured in April of year 2? So here I have to go 1/5, April 120.8. So divided by 5. So 5 twos are 10, 5 fours are 24 point something. The closest value is 25 million. So for 24 point something, when I get the closest value as 25 million, I'll mark D as the answer and move ahead. So you see, working out all the numbers in the table, even before I looked at the question, was actually a good move, right? It may have taken a little bit of time, but now there are 4 questions and 2 of them absolutely easy to solve just because I know these values that I have calculated. Let's see if the remaining 2 questions are equally solvable because of the calculations we already did. Okay. Which of the following is the approximate simple average monthly percentage change in the number of units manufactured from Feb to May? So Feb to May, how much is it changing, right? What I need to do in this case is find out what is the average change. So if I keep my Feb as 100%, right? Because I don't need to go with these values. So originally if it was Feb 100, then this became 98, then it went down by 5%, So 5% is minus 4.9. So 98 minus 4 is 94, minus 0.9 is 93.1, and then that increased by 3%. So if this increased by 3%, then 1% is 0.931, so 3% is 2.7 and 2.8, so 95.8. So overall it changed by 4.2 minus, but I'm asked the simple average. So how many times it changed? Once, twice, thrice. So 3 changes. So minus 4.2 by 3. Negative number, definitely not A. So minus 1.33 has to be the answer. Approximation, right? Works that way. My answer minus 1.33, easy one to solve. But the funda is, don't be confused by these numbers. It simply asks from Feb to May, what was the change? So consider Feb to be 100 and identify what it becomes in May, and then the change. And Feb to, the change happens 3 times, 4 months, but change happens only 3 times. So you have to divide just by 3 and check the number. Right? I hope everybody got this one. And let's see whether the 16th one based on the same data is any easy. Okay. It says the number of units manufactured in June was 12 million. Okay. So the number manufactured in June. So 132% was equal to 12 million. Which of the following was the approximate average number of units manufactured per month from May to July? So I need the approximate average of these 3, right? So 124.4, 132, 129.3, 0.7, 9 plus 2, 11 plus 4, 15, 5, 1, 3 plus 3, 6 plus 2, 8 and 3. And this divided by 3. So 3 ones are, 3 twos are 6, 3 eights are 24, 3 6 are 18, 5, 128.56, whatever, approximate it. So 128.5 will be approximately equal to what? So from 12, how do I get 132? Well, 12 ones are ones are. So 12 into 11. So something into 11 will be equal to this. So ultimately, I just need to do 128.5 divided by 11 to find the value of x. So this is 11 ones are, 11 ones are, 11 six are. So 11.6 or closest value 11.7. So 11.7 million. Easy. None of the options were too close. So I can just round off the figures. Got this one as well. So all 4 questions of the data interpretation set based on basic percentages was solvable. However, the tough point was understanding how to interpret that percentage point wala thing. And trust me, even I was stumped for a little bit. I had to rack my brains, but then remembered the fundas, right? So remember, if you understand the difference between percentage and percentage points, then this is an easy question. And like I did, I calculated the actual values compared to December of the previous year as 100. And then the questions became simple percentage and ratio proportion questions. Excellent. Moving on. Okay. Now this is what? Median? Is it statistics? Let's see what the question says. If the median of a set consisting of consecutive odd positive integers is an even integer, then the sum of the mean and range of the set is an odd integer. What do I do? Well, let's not get too worried about it. Let's break down the question step by step and understand what they're trying to say. It says the median of a set consisting of n consecutive odd positive integers. So n consecutive, I don't know what n is. N could be an odd number, even number. So let's assume that either it can be 1, 3 and 5, or it could be something like 1, 3, 5 and 7, right? The median is what? The median is always the middle value. So if it is an odd number, then the median in this case will be 3. But if 1, 3, 5, 7, if n is odd, then the average of the middle 2 numbers will be the median, which in this case should be 4. Now, it says the median is an even integer. So definitely this is not my case. So the first derivation I have is that n is an even number. The number of elements in the set is even. Great. The sum of the mean and the range of the set. Okay. So the mean is an even number. What is meant by range of the set? Well, last number minus the first number is the range. Now all the numbers are odd numbers, so odd minus odd, the range of the set is also going to be even. The median of the set is also going to be an even number. So the sum of the mean and the range, that is an even plus even, is an odd integer. Nope. The sum of two even integers can never be an odd integer. Right? So what is this? Is it an odd integer? The answer is never. Never. So question number 17, I mark C as my answer and we move ahead. Easy, easy, Japanese. Frog in my throat. Okay. Got this one? Hopefully got this one. Right? So the funda behind solving this question was first understanding what is meant by a median. Second, working out whether it's an even number of numbers or odd number of numbers. And then understanding that the range is nothing but the largest value minus the smallest value. That's the range of the set. Easy. Okay. Now, the notation is a bit wonky here, but remember this is a square, ab, b square, a minus b the whole square and a plus b the whole square. Okay. Now it says that given a and b are positive integers and a is greater than b. Great. The median of a set consisting of 5 terms a square, ab, b square, a minus b the whole square and a plus b the whole square is what? Excellent. So we always know that a is greater than b. So if a is greater than b, then a square is obviously greater than b square. And because they are positive integers, a into b will always be somewhere in between. Right? Because a is the larger number, b is the smaller number. So ab will be somewhere in between. And because they are positive integers, a plus b the whole square is definitely going to be larger than a square. So this is greater than this is greater than this. But I'm stuck with this little pesky thing. How does a minus b the whole square fit? If I take a is equal to, let us say 4 and let us say b is equal to 1, then in this case a minus b, 4 minus 1, which is 3, is greater than b. But if I say a is equal to 4 and b is equal to 3, then a minus b 1 is less than b. So I cannot identify the relationship between a minus b with the others. But it is possible that sometimes it is small, sometimes it is large. So the median of the set consisting of 5 terms, if I am not able to figure whether a minus b comes here or here, if a minus b is somewhere, then ab could be the median. But if it is somewhere else, then I'm not sure whether it is going to be there. It can be anywhere. And because of that, always and never, sometimes is relatively a safe option to mark and move ahead. It is possible to come up with a set of numbers where AB could be the median, but not necessarily true all the time, but not necessarily false all the time. Let's see. Shall we move ahead? Great. Okay. Now this says, for a set of n integers in arithmetic progression, AP, favorite. Remember, AP mein A is the first term, n is the number of terms, D is the common difference. And I hope you remember the formula. Nth term Tn is A plus n minus 1 into D. Sum of n terms is n by 2 into 2a plus n minus 1 into D. Blah, 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 blah. Just revise those formulas, guys. Okay. For a set of n integers in arithmetic progression, the difference between twice the median of the set, again median, middle number, and the range of the set, largest minus smallest, is equal to twice the first term. Very interesting. Now, I could take literally a set of numbers in AP. 135 is an AP, 123 is an AP, but I cannot be sure for the always, sometimes, never thing. So we are going to do this formulaically. So let us assume that I have a series, first term A, second term A plus D, so third term A plus 2D, so on and so forth. So the last term is A plus N minus 1 into D. Great. It says for a set of n integers, the difference between twice the median. Now remember, the median of the set, the middle value, because this is an AP, will always be the first term plus the last term divided by 2. So in this case, the value of the median of the set is the first term plus the last term, the entire thing divided by 2. So that is equal to 2a plus n minus 1 into d, the whole upon 2. Right? So twice the median of the set. So twice the median is 2 times this. 2 and 2 gets cancelled. So one value is 2a plus n minus 1 into d. Now, the difference between that and the range of the set. Now, what is the range of the set? Last term minus the first term. So a plus n minus 1 into d, last term, minus a, the first term. If the a's get cancelled, then this becomes n minus 1 into d. So the difference between 2a plus n minus 1 into d and n minus 1 into d is equal to 2a is equal to twice the first term. Definitely, formulaically I have got that it is definitely that. So the answer has to be true. Always. The answer in this case, always true. I hope everybody got this one. Right? I could have taken values of an AP 123, 135, but then I'm not sure whether the result I get is universally true. I know never will be eliminated, but I'm still confused between always and sometimes. But formulaically, if I have solved it, I can guarantee that this answer has to be true all the time. Absolutely easy. Chalo. Moving ahead then, 19th, so 20th. Okay. Oof. Two sets of numbers having medians P and Q respectively combine to form a new set. If P is greater than Q, then the median M of the new set satisfies Q is less than M less than P. Now, I can come up with some sort of cases, right? So, let us say there are two set of numbers having medians P and Q and they are combined to form a new set. So if P and Q are the medians of the two sets and P is greater than Q, that means the middle value of the first set is greater than the middle value of the second set. Then the median of the new set satisfies Q less than M less than P. That I can never be sure of. Why? Because let us say that I have P greater than Q, right? And P and Q are the medians. So let us say P is equal to 10 and Q is equal to 5. So P is greater than Q. P is the median of one set. So let us say this is the median of 11 and 9 and this is the median of 6, 5 and 4. But what if I have this as the median of 65 and 1? Right? So I do not know whether the entire set is less or more or what. I could have a combination of numbers where things go for a toss. So although I'm not very sure about what to mark, I cannot guarantee that this will always be true or never be true because I can always work around with numbers. So with great trepidation, because 19 questions, remember, we have done confidently. The 20th question, if I'm sure there is not going to be a negative marking, I may mark sometimes as the answer. If there is negative marking, I will easily leave this question on the confidence that I've got 19 questions correct. It's okay to leave this question. But if I'm a little bit of confident and I want to take a chance, or if I'm sure there is no negative marking, then the best thing to mark for this will be sometimes, right? I will try to work out cases and put it up in the comment section to prove that it is sometimes. If I am able to formulaically work it out to be either of the other two options, great. Or if you have a better solution, you can absolutely post that in the comments. But I believe 19 questions out of 20 so far is a great record. And as you can see, most of the questions were easily workable. So NPAT, at least the sample paper, was not a tough one. I tried to put up the solutions from the actual past papers of NPAT as well and see whether this level of difficulty is any different from what the actual papers are. Are there any questions left? Nope, we have reached the end of these questions. So I hope you understood the basic fundae that need to be in mind. Median seems to be a favorite because the last 3-4 questions all had the concept of median. There were 4 questions on data interpretation single set where you had to remember the concept of what is meant by percentage versus percentage point. There were a few questions which were visually solvable. Remember the 2 equilateral triangles shape thingy. The formula for a cone, I think it starred in more than one question at least. Rotation of a triangle to make a cone was definitely there, right? Basic functions was included. We saw questions of quadratics. We saw the function of simultaneous linear equations and remembering when a set of equations have infinite solutions or unique solution or no indeterminate and so on and so forth. All of these are fundas which are there in standards 8th, 9th and 10th books. So like I keep saying, hit those fundamental books. Make sure you remember all the concepts which you have learned at high school level and not just NPAT but even a supposedly tough exam like IPMAT by IIM Indore is absolutely easy to solve. Hit like, share and subscribe if you enjoyed this session. If there are any doubts, absolutely do post them in the comments. You can hit me up on social media. You can also leave comments in case you want me to come up with these sessions about any other specific paper, right? Till then, wish you all the best. Have a great day ahead. In fact, it's almost night. So have a great life ahead. May you crack the exams of your choice and get into the institution of your dreams. With that, this is me, Sathya from IQ Ideas, wishing you bye-bye.